Welcome to Guide Mia. Today we're going to talk about building a virtual patient in Cympha Studio. A virtual patient is one three-dimensional scene that holds everything you have for a single person. The CBCT volume, the intraoral scans, a facial scan, and reference photos, all aligned in one coordinate frame. This lecture is for orthodontists, oral surgeons, prosthodontists, and lab designers who need all of that data to agree with itself. By the end, you'll know how to load each modality into Studio, how to align each one to the others with a register to command, what a successful registration actually looks like, and how to save the assembled scene as a project you can reopen later. Plan on 15 to 25 minutes per patient the first time, and about half that once the workflow is muscle memory. Follow along on screen, or just listen now and read the written guide later. Let's build one. Let's define the goal first. A virtual patient is one scene where the CBCT volume, the upper and lower arch scans, optionally a facial scan, and the reference photos all live together, and crucially, all agree about where the patient is. When you rotate the camera, everything moves as one rigid whole, because every layer has been registered into the same coordinate frame. The registration Studio uses is rigid. Rotation plus translation, no scaling, no shear. You pick matching landmarks on two layers, and Studio computes the transform that maps one onto the other. And at the end, the whole assembly saves as a Cympha project, so it survives the browser tab closing and comes back exactly as you left it. That's the destination. Now let's gather the ingredients. Here's your shopping list. First, a CBCT series as a folder of DICOM files. One series, not a multi-series export. Second, one or more intraoral scans in STL, PLY, or OBJ format. Upper and lower arches usually come as separate files. If you want texture, know this now. A PLY file with UV coordinates plus its paired image is the most reliable combination. While STL is geometry only, it cannot carry a texture in this pipeline. Optionally, bring a facial scan in the same mesh formats, and any reference photos, extraoral shots, smile shots as ordinary image files. And use a wide browser window. Some Studio controls only appear at desktop widths, roughly 1024 pixels and up. Open studio.cympha.com. Nothing in this workflow needs an account or a sign-in. Before you load anything, confirm you're looking at an empty viewer. If a previous case is still hanging around, open the hamburger menu at top left and click Clear Scene. This matters because of how Studio layers work. Opening a new file only replaces its own layer. A new skin doesn't push out an old CT, and vice versa. Only Clear Scene removes everything. One more piece of setup, the workspace NAV in the top bar. A workspace is a menu filter that keeps Studio's menus appropriate for the task. 3D processing is the broadest workspace and the safest default while assembling a virtual patient. Facial scan narrows the menu down if you're focused purely on face-to-bone alignment. Step 1. The CBCT goes in first, and the order is not cosmetic. The CT is the anchor. Every other modality will be registered into the CT's patient coordinate frame. Click the hamburger menu, choose Open DICOM, and note that this is a folder picker, not a file picker. You choose the folder that contains one series. Then wait for the decode. When the volume is ready, a slice row appears across the top of the viewport and a three-dimensional rendering appears in the main view. Now open the View Tools panel. It's the small rendering icon on the floating dock that shows up on the left once the CT is loaded. Adjust the HU threshold until bone and teeth separate cleanly from soft tissue. Somewhere between 200 and 500 is a good starting point. Then set the opacity so the volume is neither a solid block nor a ghost. Keep this picture in your head for the rest of the lecture. The volume sits at the center, and everything else, arches, face, photos, joins it, never the other way around. Two side notes before we move on. If implant plans are stored in your Cympha cloud for this particular CT series, Studio may offer to import one right after the DICOM finishes loading. You're not doing implant work today, so dismiss it and continue. It will offer again next time. And remember that HU threshold slider, because it comes back later. For the facial scan step, you'll drop the threshold down into soft tissue range so the rendered face itself becomes something you can click on. Same dial, two jobs. For now, leave it in bone range, and let's bring in the first scan. Step 2. From the hamburger menu, choose Open Optical Scan File, or use Add Model on the top toolbar. They do the same thing. Select the upper arch mesh. If you have a texture PLY plus its image, hold Control and click both files in the same picker, so the image binds to the mesh as a UV texture. The mesh loads into the same three-dimensional view, but it arrives in scanner coordinates, which means it will almost certainly be floating off to the side of the CT volume in its own little world. That's expected. Fixing it is the whole next step. One picker rule worth memorizing. You can select several mesh files at once to load them all in one go, as long as there are no images in that selection. One mesh with multiple textures is not a supported combination. Now the heart of the workflow. Right-click the upper arch and choose Register to. The Register model panel opens, and Studio enters a strict alternating pick mode. A click on the source, the arch, then a click on the matching anatomy on the target, the CT. During source picks, the source mesh is the only thing visible. For target picks, the scene returns to a snapshot of what was visible when you started. Pick something unambiguous, like the mesial buccal cusp of a first molar. A reddish sphere marks the source pick. And when you click the CT, Studio walks the view ray into the volume and drops a greenish marker on the first voxel at or above the HE threshold. Now the craft point. Spread your pairs. One landmark on each side of the arch and one anterior. Never 3 points in one quadrant, because clustered landmarks let a rigid solve slide along flat anatomy. When the pairs counter reaches 3, Register lights up. Click it, and the arch snaps into place. The panel's 3 buttons do 3 genuinely different things, and knowing which is which saves real frustration. Register applies the computed transform. Cancel restores the source mesh to the exact pose it had when registration started. That's your escape hatch when the picks went wrong. Closed just dismisses the panel. Nothing applies, nothing rewinds. Use it when you open registration by accident. And if you fluff a single pick before reaching 3 pairs, press the delete key. Forward delete, not backspace, to remove the last marker. Once you're at 3 pairs, delete is locked, and cancel and restart is the way out. One more habit worth building. After a successful CT registration, right-click the mesh and turn on Show in 2D. The arch's silhouette then appears in the slice overlays, which is the quickest way to verify the alignment looks anatomically sane on axial, sagittal, and coronal slices. The lower arch gives you a choice. Option A, repeat exactly what you just did. Load the lower arch and register it directly to the CBCT, using bony landmarks like the mental foramen, the mandibular symphysis or ramus features, plus the dentition. That's the more rigorous route and the cleanest when you trust the CT. Option B, register the lower arch to the already aligned upper arch instead. Occlusal contacts and interdigitating cusps make excellent landmark pairs when the 2 scans were taken in occlusion. The lower arch lands in the patient frame by way of the upper. Pick whichever matches how the scans were captured. Together in occlusion, Option B is convenient. Captured separately, Option A is safer. Either way, you can refine afterwards. Double-click the lower mesh to open the positioning gizmo and movement panel for fine bite adjustment, or simply run Register to again against the CT. If you have a facial scan, it comes in the same way. Open optical scan file, then right-click Register to. The landmark strategy changes, though. On a face, you want bilateral and midline points. The outer corner of each eye, the soft tissue nasion, the subnasal, match to the same soft tissue features on the CT. And here's where that threshold dial earns its second job. Drop the HU threshold into soft tissue range, and the rendered face becomes pickable in the volume. Now the trap this step is famous for. When registration starts, Studio snapshots which layers are visible, and during target picks it restores exactly that snapshot. So if the CBCT was hidden when you began, your target clicks simply cannot land on it. Turn the CT back on before you open Register 2, not after. Now, the 2-dimensional material. From the hamburger menu, choose Add Pictures and multi-select your reference photos. Extraoral shots, smile shots, panoramic screenshots. These are gallery only. They live in the media gallery behind the pictures icon on the top toolbar, and they never bind to a mesh as a texture. You can attach a comment to each picture, and the comment is stored with the project, which future you will appreciate. There's also the screen capture button, the camera icon on the top toolbar. It saves the current viewer layout as a single image, including the slice panes when the CBCT layout is active, prompts for an optional comment, and stamps the file name with the time. The capture drops into the same gallery, right beside the photos you added. Time to make it permanent. Hamburger menu, save project as. On Chrome or Edge, you'll be asked to pick a folder, and Studio writes the Cympha project file, plus a sibling asset folder next to it. Project pictures land inside that folder, under a picture subfolder. On other browsers, Studio falls back to a downloaded archive. To reopen later, Choose Open Project and pick the same folder. Meshes, the CT, every registration, implant plans, if any, and the gallery with its comments all come back. So how do you know you're done, and done well? For checks. First, rotating the camera moves the volume and every mesh as one rigid scene. That's the definition of a shared coordinate frame. Second, the arch silhouettes overlay sensibly on the axial, sagittal, and coronal slices. Turn show in 2D on for each mesh if they don't draw. Third, cycle through the standard views, front, right, and left, which live on the arch toolbar when a plan case is loaded, or via reset camera otherwise, and confirm that teeth, bone, and facial soft tissue stay in coherent registration from every angle, not just the one you registered from. And fourth, save, then reopen in a fresh tab. Everything should restore, pictures and comments included. If all four hold, you have a real virtual patient. Let's take the failure modes properly, because between them, they cover almost every stuck session, and there are more of them than a single slide holds, so we'll do this in 2 passes. First, register never lights up. That means you don't have 3 complete pairs yet. 3 pairs is 6 picks, alternating source and target. Watch the pairs counter and understand what it's counting. It shows the smaller the source count and the target count. So if the scene is full of reddish markers and the counter is stuck at 0, you've been skipping the target click every time. Second, the arch snaps to a wildly wrong pose. That is almost always a landmark mismatch. The source pick and a matching target pick are on different anatomy. The other cause is clustering. All 3 landmarks in one molar quadrant produces the same instability because a rigid solve can slide along a flat region. Cancel the registration and redo it with landmarks genuinely spread across the arch third. You can't pick the CBCT during a target step. The visibility snapshot taken when registration started didn't include the CT. Press cancel, turn the CT back on in View Tools, bump the opacity above 0, and set a sensible threshold. Then run register to again. 2 more to finish. If a texture image didn't bind your mesh, the cause is UV coordinates, or their absence. STL files don't carry U versus at all, so an STL plus an image will never texture. OBJ files often lack the U versus this pipeline needs, which is why they're unreliable here. PLY with U versus is the format that works, so go back to your scanner and re-export with U versus. And the last one is the one people report as a bug when it isn't. You right-click a tooth from a loaded case, expecting to register it, and register to simply isn't in the menu. That's deliberate. Registration is only offered for meshes you added yourself. Case geometry, the tooth meshes that arrived inside a plan, carries case metadata and cannot be moved with register to, and that restriction exists to protect the plan. If tooth positions in a case could be nudged by a stray registration, the plan would no longer mean what the planner intended. So when the menu item is missing on case teeth, Studio is doing its job. Every step you just heard is written down with exact menu names and every failure mode at Cympha.com. Open the doc section and look for how to build a virtual patient in Cympha Studio. If this kind of walkthrough is useful, subscribe. We're working through every Cympha workflow, one lecture at a time. Thanks for watching, and see you in the next one.